Hi everyone. Today we're going to talk about consciousness. So a little bit about the history of how consciousness has been studied. For most of history, it was not really within the realm of neuroscience to study this topic, but neuroscientists began doing this in the early 1990s. It's a little bit unusual because most of the funding for neuroscience research is typically trying to understand neurological diseases and how we treat them. But this is a more philosophical question that neuroscientists may be able to contribute to, hopefully answering. One of the problems in trying to do this compared to other physical sciences is that you really have to study this from a first-person perspective as opposed to a third-person perspective. Meaning that, for example, a geologist has to just come up with a model that predicts observable properties of nature. However, it is a little bit more challenging to create a model that explains what it's like to be a brain from a first-person perspective. Usually, in order to even measure what it is like to be a brain from a first-person perspective, you usually can only rely on self-report. That's at least what we know of at the moment. And we know that's not the most reliable thing, but that's all you have to go off of at the moment. Okay. The majority of this video, I'm going to try to explain the parts of this paper that I understood, what neuroscientists think and don't think about consciousness. It's written by two Australian scientists, very well written. And the crux of what it argues is that essentially electromagnetic fields may be at the core of understanding consciousness. So one of the fundamental problems is that, again, every time I quote something from them, I'll put it in these little brackets. Periodic elements, like atoms and molecules that we know of, like these, have no attributes or properties that can be said to relate to consciousness or somehow aggregate or come together to produce it. There's nothing about a hydrogen proton that should tell us that we should be conscious or that consciousness is possible. There's absolutely nothing. Okay. Now, here's the argument that paper makes. The vast majority of the space in an atom is empty space. A little bit of it is occupied by the actual neutrons and protons and the electrons, but most of it is empty space. It's not necessarily empty. It actually has an electromagnetic field inside of it. That electromagnetic field is created by the charges of the protons and electrons in the actual atom. So that the majority of the space inside of an atom is occupied by electromagnetic fields. And even the majority of the spaces between atoms are occupied by electromagnetic fields. And what they say is to touch something with your finger is to engage in an interaction between the electromagnetic field system of a finger surface and the EM electromagnetic field of the touched entity. So really, fundamentally, we are just electromagnetic fields plus, some particles like neutrons, protons, electrons. But the mass majority of the space we're made up of is just electromagnetic field space, or space occupied by EM fields. And the argument that they make is that pretty much every phenomenon or pattern that we can identify in the brain essentially boils down to EM field activity. And it boils down to this principle that like charges repel like charges, and opposite charges attract. So you can basically boil any complex process in the brain down to this principle. So let's go over two examples. So let's say like action potentials and diffusion. The reason why an action potential happens is because sodium ions want to get to the inside of the cell, and then that kind of propagates throughout the entire axon. The reason that happens is because the sodium ions are positively charged, and then the inside of the axon is negative, and so then the sodium wants to come in, and then the inside gets a lot more positive, so then the potassium ions, which are also positive, want to get out. That pretty much is because of this principle again. Like charges repel and opposite charges attract. And let's go over another example. So chemical potential, or like why is it that ATP can give us the ability to run processes that are non-spontaneous? Okay. The reason is because these phosphates are all really negative, and they're kind of jammed in this little space next to each other. There's a lot of unstable, non-spontaneous repulsion that occurs. So then when you take away that repulsion, you are making this system more stable, and so then you get to make another system less stable and drive some non-spontaneous process. Essentially, everything that happens in our bodies can be boiled down to this principle in electromagnetic fields. So like, for example, the reason why proteins fold or any molecular interaction happens boils down to this essentially. And so this is kind of a bottom-up understanding of why anything happens in our bodies. And they say here, this is a quote from them, "A neuron is a collection of electromagnetic fields behaving neuronally to an observer made up of electromagnetic fields," right? The atoms and molecules that are inside of neurons are no fundamentally different than the ones that are in a rock, let's say, but it's just that the way those molecules are arranged and the electromagnetic fields they produce makes it into a neuron. This is technically true for every organ system that we have. Like, I think this highlights the pancreas. The difference with the brain is that somehow it has a specific electromagnetic configuration that gives us a first-person perspective conscious experience, which is not something that other organs can really do. So the question is then, how does the brain actually do that? And this is called the big problem, because really we don't know. So far, for the last 30 years, the prevailing paradigm for studying this has been the neural correlates of consciousness. So what we do is we take some sort of aspect of consciousness. So let's say the perception of an edge, right, when you're visioning your visual system. And we say, okay, the neural correlate of this is the activation of a specific set of neurons in the visual cortex, okay? Or let's say another aspect of experience of consciousness, say feeling touch, right? The neural correlate of that is action potentials that are occurring in your sensory motor cortex, okay? So these top-down phenomena that we kind of correlate to specific conscious experiences, there are of course many of them, like action potentials is one, thalamocortical loop behavior, neuronal excitation inhibition. They are really just aggregations of particular formations of electromagnetic fields, meaning they are specific patterns of EM fields doing stuff, right? The problem is that these abstracted top-down features that seem to correlate with aspects of consciousness seem to have no explanatory relevance to the causal basis for having any form of consciousness. Meaning, you can say that, okay, you can say that if the occipital lobe is activated, you perceive something, but that doesn't explain why that creates the perception, or why does that create the conscious experience, right? You can correlate two events, meaning not two events. You can correlate the physical activation of a specific region of neurons with a self-reported conscious experience, but you can't necessarily say why this should lead to that experience. The correlate can be right and yet deliver no actual explanation, because the electromagnetic basis of the correlate is the actual source of the origin of the claimed correlate's connection to a first-person perspective. So we can know that certain experiences are accompanied by certain patterns of brain activity, but that doesn't tell you why that has to be the case. So this is another quote from David Chalmers. He says, "Why should physical processing give rise to a rich inner life at all? It seems objectively unreasonable that it should, and yet it does." So there is no theory of consciousness, including this electromagnetic idea, really can answer this question at the moment. However, there are some other ideas for why consciousness can occur besides this electromagnetic one. One of them is this one called computation. So the idea is that the reason why we experience consciousness is because of the way our neurons are connected to each other and the underlying mathematical operations that they compute. So in order to explain this, let's think of an example that the authors of the study kind of laid out. So the computation theory goes, the way the neurons are connected is what creates consciousness. So if this theory were true, then it would have an implication, right? We create computer models of a lot of things. So we can create a computer model that simulates, for example, combustion, right? Now, one of the effects of combustion in real life is that it leads to the release of heat, right? So, for example, you combust, oil in your car, and it gets hot. If you were to do a computer simulation of that combustion, the computer wouldn't get hot, right? Even though the release of heat is a effect of the real phenomenon, it's not an effect of its simulation. The computational theory would actually imply that if you were to create a computer simulation of the brain, meaning you were to actually model every single neuron and the way it's connected to every other neuron, and you were to run that simulation, it would create real consciousness. And the reason is because what people of this theory believe is that what creates consciousness is not the specific type of or pattern of electromagnetic activity that underlies the brain. It's really the connection of neurons and what that math kind of underlies. So even though the computer is not the computer is not made up of the same types of electromagnetic waves, it's not made up of neurons, it's made up of bytes, because those bytes are connected the same way the neurons are, that would actually lead to a conscious experience for the computer somehow. Now, of course, we've not yet been able to create a perfect simulation of the brain. We don't have that. Okay. Another theory of consciousness says that our understanding of particle physics is incomplete, meaning that there are particles or waves, maybe not waves, but perhaps fields that we have yet to discover that somehow give us or confer to us some sort of first-person perspective consciousness. So they say that these particles that we think make up everything, perhaps this model is incomplete and somehow needs to be adjusted to account for conscious experience. Okay. Now, basically none of these theories can really get around this problem, which is that how does this physical world lead to this conscious experience? It really is kind of incredible. So the shorter answer is it's hard to know, but electromagnetic fields basically are the underlying reason why anything happens, so they may be the underlying reason why consciousness is experienced by us. All right. Thank you for watching, and especially thank you for the authors of this paper right here. I will leave a link to this. It's really good, so I recommend reading it. Thank you for watching.